In the Project Setting dialog box, click Next to access the following window, where you can define the structure assumption. Choose the workspace type by selecting 3D radio button. Select the Bending Rigid Structure option. Click Finish to close the Project Setting dialog box. We create subsystems that allow us to control, check, and amend better our structure. In the pilot, we right-click on Structure and select from the context menu System Management, Create a Subsystem, or we can select Structure and press F6. We define 6 subsystems, which name are portal frames, mezzanine, roof purlins, wind bracing, supports, and load areas. We select the portal frame subsystem from the pilot. The elements we are going to create will be included in the selected subsystem. We access Create a Linear Element command on the Linear Template toolbar. We make the following settings in the Linear Elements property window. We choose the linear element type as beam, material category S235, and cross-section category. In the End One cell, we access the Cross-Section Libraries dialog box. We select from the Graded Product UK Advanced Beam, and we select the UKB 406 per 178 per 67 cross-section. To draw the element, we type in the command line the first column's parameter, 0, 0, and the second, 0, 7. You can also use the snap points 0, 0 and 0, 7 of the workplane. Select the linear element and access Copy command. In Multiple Copy dialog box, select the Translation Copy mode and make sure that the rotation is disabled. Type in the vector field the element's coordinate, separated with space character 18, 0, 0. Type the number of copy elements in the number field 1. Click Preview to view the effect and confirm the action by clicking Copy. Click Close to exit the window. Select Portal Frames subsystem from the pilot. Access Create a Linear Element command and make the following settings in the Properties window: S-beam as linear element type, S235 as material, and in the End One cell, we go to the Cross-Section Library and we select from the Graded Product UK Advanced Beam the UKB 254 per 146 per 31 cross-section. Place the cursor on the top of the first column, then type the coordinates of the second extremity of the rafter, 9, 8, and press Enter. To draw the second rafter with the linear element drawing tool activated, place the cursor at the extremities of the first rafter and the second column. Select the mezzanine subsystem from the pilot. Access Create a Linear Element and make the following settings in the property windows: S-beam as a linear element type, S235 as material, and then we change in the End One cell the cross-section. We access Cross-Section Library, Graded Product, UK Advanced Column, and we select the UKC 203 per 46. We draw the mezzanine column, typing in the command line the start 70 and the end 73.5 coordinates. To draw the mezzanine beam, we right-click in the drawing area, and from the context menu we select Snap Modes to access the Snap Modes dialog box. Select the perpendicular option. Draw the mezzanine beam, placing the cursor on the mezzanine column top extremity and on the portal frame column's perpendicular snap point. Select then the Supports subsystem from the pilot. Access Create a Rigid Point Support command on the Supports toolbar. In the Supports property window, select the restraint type as pinned. Using the snap modes, place the supports at the base of the 3 column. Press ESC to deactivate the current drawing tool. In the pilot, select Loading, right-click and select from the context menu, Create several case families. A dialog box appears, and we type 1 for dead loads and 1 for live loads family. Clicking Create, 2 load cases are now displayed in the pilot. Select Live Load Case from the pilot and access Create a Point Load command from the Load Case and Loads toolbar. In the Point Load Properties window, define the force intensity Fz minus 5 kN. Then create the loads by clicking on the top of each column and on the joint between the two rafters. You can update the load scale activating the command Loads Autoscale in the context menu that you can access with a right click in the drawing area. Switch the view to -1, -1, 1, pressing Alt 5 or going to the predefined Views toolbar. Select all the structures element. From the drop-down list on the Filter and Selection toolbar, choose Selection by All or use Ctrl-A shortcut. Access Copy command and select the Translation Copy mode. Make sure that the rotation is disabled. Type the vector field in the element's coordinate, separated with spaced characters. 0, -6, 0. Type the number of copies element in the number field, 5. Click Preview to view the effect and confirm the action by clicking Copy. On the Zoom toolbar, click Zoom All or press Alt-A keys to view all the elements from the drawing area. Select the roof purlin subsystem from the pilot. Access Create a Linear Element command and make the following settings in the Property window. S-beam as a linear element type, S235 as material, and access Cross-Section Libraries dialog box by clicking the button on the end one cell and select from the Graded Product UK Advanced Beam 127x76x13 cross-section. Place the cursor at the extremities of the first rafter and the last rafter of the framework. To modify the eccentricity and orientation of the purlin, access Create a Point command and place the point on the rafter joint on the first portal frame. Make the following setting in the Property window of the purlin. Eccentricity 0 Z+. Orientation, define the angle at 90 degrees and enter the point ID1. The orientation of the purlin will refer to the specified point. In the drawing area, select the purlin you have drawn and access the Copy command. Select the Translation Copy mode and select the second translation copy type. To define the copy vector, click Define a vector, then place the cursor on the two extremities of the first rafter. Type the number of copied elements in the number field, 6. Click Preview to view the effect and confirm the action by clicking Copy. Select the top purlin and remove the angle and the ID under Orientation in the Property window. Select the 6 purlin, except the top one. You can copy the roof purlin using various methods. By symmetry, starting from the Symmetry window. On the Cut function toolbar in Home, click Symmetry to access the Symmetry dialog box. Activate the Copy mode and click the Plane Symmetry type. Choose the reference element for the plane symmetry. Click the Definition button and in the drawing area, place the cursor on the top purlin. Choose the plane coordinates for the symmetric copy from the drop-down list, YZ. Click Preview to view the effect and confirm the action by clicking Apply. You can also use the Symmetry Tool button from the Cut function toolbar in Home to access the Plane Symmetry command. Place the cursor on the top purlin and take it into account as reference element for the vertical plane symmetry. Notice that a preview of the copied element is available. Click to perform the copy of the selected element. If not, you can copy by rotation. You select the 6 purlin and click the rotation command in the Cut function. A message in the command line asks to define the rotation axis. Type P to perform a 2-point axis definition. The following message in the command line asks you to define the start and the end point of the rotation axis. Click each of the extremities of the third purlin to define this element as the rotation axis. The final messages in the command line ask to define the vector for the element rotation. For the first point, click the left extremity of the front rafter. Then, to define the second point, move the cursor to the right extremity of the rafter and click to place the copied purlin. Select the purlins you have copied and modify the local axis, checking that the local axis in that direction is looking outward. Select the mezzanine subsystem from the pilot. Access Create a linear element in the property window and choose as a linear element type S-beam, category of the material S235 and cross-section 203 x 203 x 46 UKC from the drop-down list in the End 1 cell. Draw the mezzanine beam connecting the portal frames at the mezzanine level. Select the mezzanine subsystem from the pilot. Access Create a plate element command button from the linear in plate toolbar. Choose as plate element type shell, as material category C3037, and in thickness category type 150 mm for the first vertex value. Draw the mezzanine slab, snapping at the extremities of the beams previously created. Now we display all the structure by clicking Display All. And then we go to the portal frame, we right click and we isolate the portal frame elements. Then we access Linear Elements tool. Choose the linear element type as bar, material category 235, and access the cross-section library dialog box and select from the graded product UK Advanced Celsius GHS and select the 33.7 x 33.7 x 4 GHS cross-section. We select now the wind bracing subsystem and we access Chain Linear Element. Using the available snap mode, draw the wind bracing as shown. We then right-click on the wind bracing subsystem and we click on Select to select all the elements. We hold Ctrl and we copy the element just by dragging them using the snap point. Select the Load Areas subsystem from the pilot. Access Create a Load Area Element command on the Linear in Plate toolbar. Draw the load areas on the framework lateral sides and on the roof slope. The X direction is given by the first 2 points you snap to, and the Y direction is given from the following snap point. Define the direction of the span of the front load area towards them. Makes these settings for all load areas in the span direction category of the property window. To check if the span direction is the right one, we use the render modes. We select axis and linear contour and we see the span direction in a more clean way. We change the span direction of the roof load areas. Then we change the render mode to profile and shaded faces. We hide the load areas by right-clicking on the subsystem and clicking Hide. The plate element is not in the right subsystem. To change a subsystem, you can easily select the element and then modify the system in the properties. In this case, the element belongs to the mezzanine subsystem, that is, the number 2. In the pilot, select the live load case and access Create an area load. Then type the FZ intensity, -3 kN. Draw the area load placing the cursor on the corner of each span of the mezzanine slab. To display all the models element on the Filter and Selection toolbar, click the Show All button. In the pilot, right-click Loading and select from the context menu Create a Case Family. Select Wind Load and a wind family is created in the pilot. Within Advanced Design, you can create automatic wind loads. We isolate the element of the mezzanine, and then we select the plate element, and we disable the option Supporting element for wind and snow. We do the same for the linear elements that are in the same plane of the area loads but are not supporting directly wind and snow load. These elements are the external linear element of the mezzanine and the wind bracing that we are going to isolate, select, and then uncheck the box. In the property window, select the wind speed as 22 meters per second in the wind speed regions. Right-click on the wind load family and select Automatic Generation from the context menu. This command will automatically create wind load cases and the corresponding loads. In the pilot, under Analysis Settings group, select Combination. Right-click and select from the context menu Properties. Click on the Simplified Combination command to access the automatic generation of the Eurocode combination. Select Generate on the Eurocode combination option dialogs. Click OK to apply and exit. We now go to Analysis, we select FE calculation, and we run the analysis. The mesh is creating, taking into account that the bar elements are not going to be intersecting. Now the post-processing table is enabled. We go to the front view and we select the displacement of the combination number 7. We want to display the value in the nodes. So we go to Option in the result setting and we tick the box Values and Extreme Values in the window. If you want to see only the maximum value, you can also select only Extreme Values. We now display the forces on linear element and plates. We are going to select My for the linear elements and Myy for the plate elements, and we display the forces for the self-weight case. We then display the shear forces for both of the elements. We are going to select Fz for the linear element and Fzz for the plate elements, and we click on post-processing.